is multiplying and dividing rational expressions. So basically, you guys have learned how to multiply and divide fractions, normal fractions, with numbers. And now we're going to learn how to multiply and divide rational functions, which are fractions that have like polynomials on the top and polynomials on the bottom. So we're going to be factoring and reducing. So it says we simplify rational expressions in the same way that we simplify easy fractions. So for instance, if you were reducing 15 over 24, you could break the numerator into their common factors. So what is in common with 15 and 24? 3, right? So we think about this in our head as being 3 times 5 over 3 times 8, and we say, oh, they're both divisible by 3, so I'm going to reduce it down by dividing by 3 and dividing by 3, and then we get 5/8, right? So that's what we're going to do with these. So we're going to try to take our rational expressions, which are basically like things like 5 over x squared minus 9 over x plus 3, right? We're going to take those things and we're going to factor them and reduce out any common factors, okay? So the first one, I have 10x the 8th over 6x the 4th. Okay, so let's think about just those numbers, the 10 and the 6. What do the 10 and the 6 have in common? 2. So what we're thinking of this as is 2 times 5 over 2 times 3. And then our x's, we have 8 x's along the top, and we have 4 x's along the bottom. Well, we've done this. We've done this in an early chapter, like chapter 5, where we reduced out x the 8th over x the 5th. Do you guys remember we would think, okay, we have 8 x's, and we have 4 x's, and we're dividing by x, right? And so 4 of them cancel on the top and bottom. Do you guys remember the rule that we ended up learning? Like we have 8 on top and 4 on the bottom. How did we know how many were on the bottom? Yeah, we subtracted those exponents. Do you guys all remember that? So this ends up being x to the 4th. And our 2 and our 2 reduce out. So it reduces out to 5x to the 4th all over 3. So you're just canceling your common factors. That's all we're doing. So the next one is a little bit tricky for students at first because they always want to cancel those x squareds and they want to cancel the x's and so on. That's not what we're doing. So let's think about numbers, okay? So if I had like 2 plus 3 over 2 plus 4, tell me what the result is there. It is what over what? 5 over 6. We all understand that concept, correct? We understand that we have to add these together and get 5 all over 6. Is it the same as if I canceled? So can I just cancel the 2's? No, 3/4 is not the same as 5 over 6. We all understand that concept. Okay, so for the same reasoning, when we have something like x squared plus x minus 2 over x squared plus 2x minus 3, we cannot cancel these x squareds, okay? Everybody always tries to do that on the test, not everybody, but I always have like 5 students every test that try to do that. Okay, we're not going to be those students, correct? Yes, yes ma'am. All right, so we know that we have to factor things. We have to factor in order to have like something being multiplied that reduces. That's what we're doing. So we're going to factor the top in its 2 sets of parentheses, and we're going to factor the bottom in its 2 sets of parentheses. I told you factoring would never go away for the rest of Algebra 2. Sometimes people don't believe me. They're like, oh, it's fine. I don't need to know this. All right, so I'm going to have x and x, and I'm going to need a 2 and a 1 in order to multiply to be 2. They need to be negative 2, so I need the opposite signs. So let's look at our outer and inner swoops. So we have 2x and 1x. We want it to combine to be positive 1x. So we're going to do the negative 1 and the positive 2. Perfect. So on the bottom, I'm going to have x and x. And I know I need 3 and 1. And again, I can think about my outer and inner terms. So outer and inner need to combine to be positive 2. So I'm going to have a positive 3, but a negative 1, right? Here's my hint. If you can't figure out how to factor it, but you've gotten at least the top, if you're like, oh, the top part factored, probably one of those factors is going to be the same in this chapter. Do you guys understand? Because we're probably going to cancel them, right? So if you're like, I can't factor the bottom, what's the problem? Then maybe you should try x minus 1 as 1 apart, okay? That will help on those more complicated factoring ones. All right, so we have x minus 1 in common. That's all being multiplied by x plus 2. It's all being multiplied by x plus 3. So we can cancel that out because now it's like these ones where we had something multiplied, right? 3 times 5 over 3 times 8. So when we cancel it, we end up with x plus 2 over x plus 3. And then we're done. We do not cancel those x's. Again, do we understand why we don't cancel the x's? Yeah. All right, so let's factor the next one. So on the top, we have a GCF that we can pull out. So we can pull out an x. And when we do, we get 4 minus x. On the bottom, we have x minus 4, and we have x plus 2. Now the factor on top and bottom do not look the same, right? I have 4 minus x and I have x minus 4, which they're similar, but they're not exactly the same. Any ideas? Yep, that's right. So let's take out a -1 from the top one. So I'm going to pull out a -1, and when I do you see how I'd have -4 plus x like that if I pulled out a -1? So this one right here. If I pull out a -1, I have -4 plus x. Well, isn't that the same as x plus 4? Or, yeah, oh, x minus 4. Darn. X minus 4. Eric got a bonus point. He caught me. All right, and then on the bottom, I have x plus 2. So now can we cancel? Yeah, we can cancel that x minus 4, right? So our final answer is going to be -x on top over x plus 2. Done. Okay, so if you recognize that two terms are the opposite of each other, like for instance, if you had 5 minus x on top and x minus 5 on the bottom, we don't have to do that inner step. We can say, oh, those are going to cancel, but what am I going to be left with? What do I put on top? A -1, right? So when those cancel, make sure you write -1. Okay, so you can kind of shortcut that process. All right. So it says you can also multiply rational expressions just like fractions. So if you remember way back when you first learned fractions, think about things like 27 over 16 and 24 over 81. Chris, you with me? So Chris, would you multiply 27 times 24 over 16 times 81? Would you do all of that? No. There's an easier way, right? What would you do? Yeah, you try to simplify first, right? So we're going to try to simplify. So any common factor that's on the top can simplify with any common factor on the bottom. So maybe they don't have, like 27 and 16, those don't have anything in common there. But remember, we would be multiplying everything across the top. We'd have 27 times 24 on top, and then 16 times 81 on the bottom. So really anything that's on the top can cancel with anything that's on the bottom. So let's look through. How about the 16 and 24? Can those reduce out? Yeah, 4 can go into anything bigger. 8, yeah, so we can make this 3 and 2. And then the 27 and 81, that might be a little bit harder. 3 goes into it definitely, so 9 goes into it, yeah, so I could have 9 and 3. So right now I have 3 over 2 times 3 over 9. Can I go any further? Yeah, 3 and 9. So make 1 and 3. So right now I have 3 over 2 times 1 over 3. Can I go even further? How about this 3 and the 3, right? 1 and 1. This all simplifies down to 1/2. That's it. So did we want to do 27 times 24 over 16 times 81? No, I don't know what 27 times 24 is. I would have to use a calculator. Even me, as a math teacher, I would need a calculator. So don't overcomplicate things. Don't multiply things out if you don't have to. And this happens also every year on the test where people will get things like, I don't know, things like this. I know it says division in here. So imagine flipping it, and then they're foiling out like this one times this one. They're multiplying that all out. That's crazy. Don't do that. Like that takes a really long time, and it's very complicated. So we're not going to do that. We're going to know to always simplify first.
Can you do that problem?
Yeah, we're going to, yeah. Okay, so number 1. So this one, these are all like monomials. They're all like grouped together, right? We don't have any pluses or minuses. So we could simplify everything that's here, and we can simplify everything that's here. Or really, you could reduce anything that's on top with anything on bottom. But let's start with the red circle and then the blue circle. So in my red circle, I would have 3 and a 2. So 3 over 2. How about the x's? What do those reduce down to? X squared. And the y's? Y to the 4th on the bottom, right? So you could say y to the -4, but I always put it in the correct location and just make it positive. All right, how about the blue one? So we still have the 10 and the 9. How about our x's? X on top. and y on the bottom, right? So let's start reducing out these numbers. So my 3 and my 9 can reduce to 1 and a 3. And the 10 and the 2 can reduce to a 5 and a 1. So right now I have 5, and I have x squared times x, so I'm going to write x cubed over 3, and I have y to the 4th times y, which is y to the 5th. So quick check, can it go down any further? No, because I don't have any x's on top and bottom, or y's on top and bottom, so I am done. That's your answer. So now let's try the next one. So these ones are different. These ones are not monomials. They have pluses and minuses and so on. So this is where you have to be careful, and you can't do those things we were talking about with like x over x squared reduces to 1 over x, right? Because that x is attached to the plus 5, and the x squared is attached to the minus 9. So we have to factor all of these things. So on the first set, when I factor it, I'm going to have x minus 3. And the bottom part does factor. Close. How do we factor this? So, yeah, it has a GCF. So we have that 4, right? So we're going to pull out the 4, and we're going to have x plus 5 like that. So those are the ones that sometimes people overlook because they're like, oh, it's just x the first, it's not going to factor. But actually, there's a GCF. So look for those GCFs. All right, and then the next one, so I have x plus 5, and then on the bottom I have x squared minus 9, which we know factors into what?
X minus 3 squared.
X plus 3 and x minus 3. Be careful, difference of two squares, right? That way we don't have that middle term. It's like a 0x in the middle. Now we're ready to start reducing. That's the fun part. I always like canceling lots of things. All right, so we have x minus 3 and x minus 3. Those cancel. We have x plus 5 and x plus 5. Those cancel. Anything else? No, I've canceled everything on the top. Do I write 0? No, I write 1, just like fractions, right? Just like when you multiplied fractions, if everything canceled on top, we write a 1. So I have 1 over 4 times x plus 3. And I would just leave it like that. You could write 1 over 4x plus 12.
Is that not right?
I usually just leave it in its factored form just in case you see any other factors that can reduce out. Okay, that one is okay. This next one's a little bit harder. So let's see if we can do it. So I have 1 minus x to the 4th. That's the difference of two squares, right? It might bother some of you guys. You might not like seeing 1 minus x to the 4th. So you might think, oh, I can pull out a negative 1, and then I could have x to the 4th minus 1. You can do that if you want to, if it bothers you. Or you can keep it as 1 minus x to the 4th and say, oh, that's 1 plus x squared times 1 minus x squared, right? The difference of two squares. That 1 minus x squared will go further, but we'll do that on the next step. All right, so then I have x to the 4th minus x. Well, that has a GCF, so I pull out an x. And I have x cubed minus 1. Oh, man. And then I have x squared on top. And on the bottom, I have x to the 4th plus 2x squared plus 1. So that's going to factor into x squared plus 1 times x squared plus 1. Do you guys see how it's, if you FOIL it out, like you're going to have x squared times x squared makes x to the 4th. My outer and inner are 1x squared and 1x squared, which combine to 2x squared, and the 1 make 1. So we're kind of getting there. Yeah, that 1 plus x squared and the x squared plus 1 go away. How about the x squared and the x? Yeah, you can cancel them, but you're going to have what left on the top? One of those x's, right? So I'm going to cancel, and I'm going to have an x. It's always hard to cancel x's. Sometimes I circle it and cancel. All right. So the bottom, well, the top, I have 1 minus x squared. How does that factor? 1 minus x squared is 1 plus x times 1 minus x. It's the difference of two squares. So this one's testing to see if you really remember your factoring. Do you guys remember when you have x cubed minus 1? It's the binomial and trinomial, the difference of two cubes. SOAP, do you guys remember SOAP? So we want to think about what's being cubed. We have the x is being cubed and the 1 is being cubed. That's like our a and our b in the formula, if you use the formula. So in the first parentheses, I drop my cubes. So I'm going to have x minus 1. And in the second parenthesis, I have 3 spots. In the first spot, I square the first item. So x times x makes x squared. In the last spot, I square the last item. 1 times 1 is 1. In the middle spot, I multiply the 2 together. 1 times x is 1x. And my signs in the end are SOAP. Same, opposite, always positive. So we have the same as what we had originally. We have opposite what we had originally. And we have plus at the end. So this factors into x minus 1 times x squared plus x plus 1. And then on the next one, I have x, and then I do x squared plus 1. So is there anything else that reduces out? Yeah, the x minus 1 and the 1 minus x. And what do I write when I reduce those out? Yeah, that's where I get that negative 1. So I cancel, and I'm going to gain a negative 1 through that. So your final form is negative 1 times 1 plus x times x all over x squared plus x plus 1 times x squared plus 1. Not very simplified, is it? They aren't that hard on your homework. I don't do any cubes on your homework. Does that make you feel better? Or are you guys like, oh, sum and difference of cubes, oh no. All right, so let's talk about dividing. So we know that if we have 2 fractions divided, if I had 3/4 divided by 5/6, what do I do? Yeah, I like multiply by the reciprocal. Which one? The first one? The second one, right? I do 3/4 times 6/5, right? Right? Do we all remember that? So that's what we're going to do here. So when we have a division sign, we're going to rewrite it so we see multiplication. So I'm going to have 5x the 4th over 8x squared y squared times, and I'm going to put 8y to the 5th over 15. Okay, and then I start reducing out just like before. So like the 5 and the 15 reduce, and I have a 1 and a 3. And the 8 and the 8 reduce, so I have a 1 and a 1. Chris, you trying it? So how about the x's? So on top I have x the 4th, on the bottom I have x squared. Yeah, I'm going to get x squared on the top. Perfect. So those are going to cancel, and I'm going to be left with x squared. How about the y's? Y to the 5th, y squared, so I get y cubed on top. So it gets a little bit messy when we have all these canceling. So you can do it in multiple steps if you need to. So we have 1 times x squared times y cubed on the top, which becomes x squared y cubed. And on the bottom I just have 1 times 3, which is 3. That's our final answer. All right, and then on the next one, so again I have divided by, so I'm going to do times, and I'm going to flip. So if you want to start factoring, you can before you flip, or you can just flip first, or factor as you go. So let's say I flip first, and then I do times, and I'm going to put the x squared minus 16 on the top, and the x to the 4th plus 2x cubed minus 8x squared on the bottom. So kind of try it along with me. So think, are there any GCFs that I can pull out? How do I factor these things? So let's start with the x to the 4th minus 9x squared. So the first thing we would do to factor is pull out that GCF. So we should have an x squared, and then I'm left with x squared minus 9. Okay, that will factor further. So we'll leave it for now. On the bottom, I have x squared minus 4x plus 3. So I set up my 2 sets of parentheses. X minus 3 and x minus 1, perfect. On the top, I have x squared minus 16. It's the difference of 2 squares. X plus 4 and x minus 4. And on the bottom, I have a GCF first, so I'm going to pull out an x squared. So I get x squared plus 2x minus 8. So right now there's only one thing that's canceling. The x squared, right? I recommend using colors too on your homework. It helps. Color pencils. So now we can factor those, the x squared minus 9 and that x squared minus 2x minus 8. So let's factor those. So x squared minus 9, all of you should know how to factor that. It's the difference of two squares. X plus 3 times x minus 3, which is going to give us the x minus 3 that cancels with the bottom, right? And then I have that x plus 4, x minus 4, so when I'm factoring the bottom, I'm going to have my x, and I'm probably going to have a 4, I would guess. So 4 and 2. Our outer and inner need to combine to be positive 2. So I need a plus with the 4 and a minus with the 2. So now I start canceling, the fun part, right? X plus 4 and x plus 4 cancel. X minus 3 and x minus 3 cancel. But unfortunately, this one doesn't go all the way. I mean, there's nothing else that it does. I like when it goes like all the way down and it's like 1/3. You're like, whoa, that worked out, right? So this one doesn't go much further. So we're going to leave it as x plus 3 times x minus 4 all over x minus 1 times x minus 2. So we just leave it like that. You don't have to multiply it out. Because if you make a mistake, we don't want to make a mistake in foiling it out, right? Nope, you actually can't. Yeah, they would have to be exactly the same in order to simplify. And if you get confused, you can always plug in a number. I like plugging in 7. So I'm like, okay, what if I had 7 there? 7 minus 4 would be 3. 7 minus 2 would be 5. Can you reduce out 3/5 anymore? No. So that's one way to check, kind of, if you can simplify it. All right, we good so far? You guys got it? All right. Let's try the next one. Yeah, I kind of like, yeah, it's a good one to plug in. Because what if you had like 6 that you plugged in and then they have an even factor in common? Yeah. All right. Maybe, yeah, 1 would probably work. You guys want to try the next 2? See how you do? All right, try them. We'll see. All right, so the first one, so we're going to pull out the 5 first. So you guys should have 5 times x plus 5. And on the bottom, you should have 4 times x minus 5. Let's see, so negative 4 times x plus 5. That would be negative 4x minus 20. So we didn't actually have negative 4x, did we? So I think you can't do that. All right, so then on the next part, it's divided by. So I'm going to do this step in 1. I'm going to flip it. So I'm going to have 12x on top, and then I'm going to factor the bottom. So I had x squared minus 25, which is going to be x plus 5 times x minus 5. Now I start reducing. So I have an x plus 5 and an x plus 5 that reduce. I have a 12 and a 4 that reduce to 3 and a 1. But there's really nothing else I can cancel because I have this x minus 5 and this x minus 5, but one of them's not on top and one of them's, you know, like on top and bottom, right? They're both on the bottom, so we can't reduce those out, okay? So that means our final answer should be 15, right? 5 times 3, x all over x minus 5 times itself. So you could get fancy and you could say x minus 5 squared if you want to. Or just write x minus 5 times x minus 5. All right, did anybody get that? Yeah, several of you guys, good. All right, so the next one. So I'm going to pull out the 7, and when I do, I have x plus 2. And on the bottom, I have x cubed minus 8. Uh-oh, that's the cubes thing. So I'm going to factor into x minus 2 times x squared plus 2x plus 4. Did you guys factor that correctly? So then I'm going to flip the other side. So I'm going to have x squared minus 4 factors into x plus 2 times x minus 2. And the denominator factors with a GCF into negative 2 times x plus 2. Okay, so those should be your factorings on all of them. So check your factoring. Make sure you had it correct. Negative 2 times x plus 2. Because it was coming from here. You're pulling out the GCF. All right, now we start canceling. So we know that we have the x plus 2 in common on top and bottom. We have an x minus 2 in common, but there's really nothing else. So our final answer should look like 7 times x plus 2 over negative 2 times x squared plus 2x plus 4. Did anybody get those ones all the way correct? Did you guys get it? Good. Oh, I didn't put a negative. Oh, man. So let's put the negative. It can go on the top or it can go on the bottom. It doesn't matter. All right, does this make sense? You guys get it? All right, so we're going to stop there for today. So we're breaking up this section a little bit. I'll do the next part tomorrow. All right, so the next portion says you can solve rational equations, but make sure you check your solution. So remember, some numbers could have made the original rational expression undefined. So there are numbers that make our rational expression undefined. So I don't know if we talked about this before, but basically, like when you have a rational expression like 5 over x squared minus 9 over x plus 3, 10 over x squared minus 5, like there are certain things that I can't plug in for 0 because it makes it undefined. So with 5 over x, what can I not plug in for? Sorry, I said for 0. What can I not plug in for x? Because I'll get 0 in the denominator. 0, right? How about the next one? What can I not plug in? I can't plug in negative 3. So I realized that x squared minus 9 over x plus 3 factors, right? And then you would remove that x plus 3. But in the original problem, you still can't plug in negative 3. It makes it undefined. Okay, if I was doing like a t-table or something, I would get undefined. Okay, so that's what it's talking about here. So sometimes, even though you get an answer, you want to check in the original just to make sure that it's okay. So there are a couple different ways to do these problems. So one thing that you could do is you could take the x minus 5 and you could multiply it to the other side. Okay, so look up here. You don't have to write this down, just pay attention. Okay, so if I do that, I would have x squared minus 25 equals 14 times x minus 5. And I would then multiply out. And I would get everything on one side. So I'd have x squared minus 14x. And then I'm going to add the 70 over. So I'd have plus 45. And then I factor. So I would factor into x minus 4, or not x minus 4, x minus 5 and x minus 9. So we would get two solutions. We would get 5 and 9. But if we went back to the original equation and we checked 5, so we plugged in 5 to the numerator, 5 to the denominator, do you guys see how you would have 25 minus 25, which is 0, over 5 minus 5, which is 0? Is 0 divided by 0 equal to 14? No, it's undefined, right? We don't know what 0 divided by 0 is. So 5 would be one of those extraneous solutions. So it would be extra. So that would not work. So then 9, if you try 9, you'd have 81 minus 25 over 4. So you'd have 56 over 4, which is 14. Okay, so that one would work. Okay, but there's an easier way to solving this problem. So does anybody kind of see what we would do here? Gloria, what do you think? Yeah, in this case, we could factor. So if we factor from the beginning, and we say, oh, I have x plus 5, and I have x minus 5, all over x minus 5. So go ahead and write this down now. Whoops, not equals 0, equals 14. Then when we do that, that x minus 5 cancels. And we're left with a super simple equation, x plus 5 is equal to 14. So we end up getting 9. That is our only solution. You can check 9. So just like I did before, check 9, you get 56 over 4, and that is equal to 14. So that one worked. It checked out. Okay, does that make sense? So it's easier to factor and eliminate the one that was going to be bad anyway, if possible. So on this next one, if I factor, I have x squared plus 3x minus 10. So I factor into x plus 5 and x minus 2, right? So my outer and inner combine to be that 3x. And then it's over x minus 2. So those x minus 2's cancel. So we have x plus 5 equals 7. Thank you. So I get x equals 2. But you should still go back and check. Okay, what happens if you check 2? Look at the denominator. Yeah, you get that 0 in the denominator. So does it work? No, it actually doesn't. So this one doesn't work when we check it. So it's no solution. So don't just assume because you factored that it's like, oh, I got rid of the bad solution. You did get rid of a bad solution, but the other one could be bad as well. Okay, and then sometimes it doesn't factor. So this next one I have x squared minus 2x plus 9 all over x plus 5 equals 3. Okay, and it doesn't factor. So in this case, you actually would have to do that longer method. You're going to take the denominator and you're going to multiply it to the other side. So we're going to have x squared minus 2x plus 9 equals 3 times x plus 5. Like that. So I have x squared minus 2x plus 9 equals 3x plus 15. And I get everything on one side. So some of you guys had trouble with this on the conic sections test because there was one problem where it was like x squared minus 2x equals 3. And then you guys were like, I don't know how to solve this. But you just get it on one side and you factor, right? Like it was like a panic moment on the test. Like, wait, what am I doing? All right, so on this one, I'm going to get everything on one side. So I have x squared. I'm going to have minus 5x. I'm going to subtract the 15 over. So 9 minus 15 is negative 6. And then I factor. So it factors into x minus 6 times x plus 1 because I need them to multiply to be that negative 6. So we get 6 and we get negative 1. So we still need to check. So how about this side of the room? So from Logan and Anna Catherine over, you guys check the 6. And the rest of you guys, you tried negative 1. Let's see if they work. Oh, I don't know why I did 12 there. 36. It's already moving on to the next one, wasn't I? 6 does work. So it all equals 3. Okay, and negative 1 does work? It does. So you have negative 1 squared plus 2 times negative 1 plus 9, and it does all equal 3. So they both work. So sometimes you can have 2 answers as well that work. Okay, does this make sense? So this is solving equations that have rational expressions. Okay, so let's get to the weird stuff. So look at this problem. Doesn't this look so fun? This 9x squared minus 4 over x minus 2 divided by, ooh-wee. So that's what it says in the notes. So it says sometimes we've seen crazy fractions within fractions. So these are called complex fractions. I don't know why they call them complex fractions. There are no complex numbers in them. I guess it's complex as in difficult. They're difficult fractions. Not really that hard. You guys can do these. No such thing, right? So a complex fraction contains one or more fractions, and its numerator, denominator, or both. So it says try simplifying the complex fraction. So if you have 1/2 divided by 3/5, so I just read that like this, 1/2 divided by 3/5. So the division sign with the 2 dots in the line. That's called an obelus. That's simple. So I have 1/2 divided by 3/5. So we know how to do that. We just did that yesterday, right? So if I'm dividing by 3/5, what am I really doing? Multiplying by 5/3, right? So we're going to change it. So we're going to say, okay, well, I have 1/2, and I'm multiplying by 5 over 3. So when I get that, I get 5 over 6. So we do exactly the same thing with these ones. So we think of it as 2 separate fractions with a division sign in between them. So we're going to say, okay, well, I really have 9x minus 4 over x minus 2, and I'm dividing by 3x plus 2 over x squared minus 3x plus 2. So you guys did this on your homework that you started. So we're going to factor the 9x squared minus 4. So it's going to be 3x plus 2 times 3x minus 2 all over x minus 2. And then we're going to do times, so we're going to flip that second fraction. So the 3x plus 2 that was on the top before is now on the bottom. And that x squared minus 3x plus 2 is going to factor into x minus 2 and x minus 1. So we cancel any common factors, x minus 2, 3x plus 2, 3x plus 2. So it looks like our final answer would be 3x minus 2 times the quantity of x minus 1. And that's it. All right, so the next one's a little bit harder because now we have an addition or subtraction sign with the fractions, right? So it gets a little bit weird. So if I was going to do this one, I would do my 3 over x plus x over 2 in parentheses, and then we're dividing by x minus 1 over x. And we're going to get common denominators. Okay, so we're actually going to be talking about this in 9.2, getting common denominators. But what do you guys think? So sometimes I have to think about a number plugging in, and remember I said 7 is always a good number to plug in. So if I had 3 over 7 plus 7 over 2, how would I get common denominators there? 2 over 2 and 7 over 7, right? So that's what we're doing here. So I'm going to take my 3 over x and I'm going to multiply by 2 over 2, and I'm going to take my x over 2 and I'm going to multiply by x over x. Sorry, it's kind of hard to see there. That's x over x. So when I do, I get 6 over 2x plus x squared over 2x, all in parentheses. And then it was divided by the x minus 1 over x. So now that we have common denominators, so who can tell me, what do you think this is? 6 over 2x plus x squared over 2x. Yeah, 6 plus the x squared all over 2x. Not 4x, 2x, right? So keep those denominators the same. So we have 6 plus x squared all over 2x, right? Common denominators. Right? And then we do times, and we flip the second fraction. So I'm going to do x over x minus 1. So really the only thing that reduces out here are these x's. So x and x cancel. So we get 6 plus x squared, or x squared plus 6 if you want to write it that way, and then we have a 2 times x minus 1, and that's our answer. Okay. So there's actually a little bit of an easier way of doing this. So I can show you another shortcut, especially when you have like actual numbers. So let me go back up here. Well, I'll find some more room. You guys have a little bit of space underneath what you did. So let's say we had something and we had 1/2 plus 3/8 all over 5/4. So similar to what we just did, a fraction added to another fraction all over another fraction. If you are able to get the common denominator of all of those, so looking at the denominators, I have 2, 8, and 4. What would the common denominator of all of them be? 8. There's a quicker way of doing this. And this is just kind of a good skill to know in your math classes. We like clearing fractions, right? It's the way to clear fractions within fractions. So the least common denominator would be 8. So we multiply the entire numerator and the entire denominator by 8. That's allowed, right? We're multiplying the top and the bottom by 8, so it's like multiplying by 1. So when we do, we get 8 times 1/2 is 4. 8 times 3/8, what do we think? 3, right? 8 times 3 over 8. All over 8 times 5/4. Well, 8 times 5 over 4, what's that? Yeah, 40 over 4, which is 10. And right away we get 7 over 10. Done. That's an easier way of doing that. So on this other one, what would be our least common denominator for all of them? So if I have 3 over x plus x over 2 all over x minus 1 over x. Not just x though, be careful. So I agree, x is part of it, but what else? A 2. So we're going to say 2x over 2x. And then we multiply that 2x into both things. So think about if I had 2x. So if I have 2x times 3 over x. 6x over x, right? And 6x over x is what? 6. So we get 6. And then if I have 2x times x over 2, 1 what? X squared. So I get 6 plus x squared all over. Now I have the 2x times x minus 1 over x. That's where our x's are going to cancel. So we're going to have 2 times x minus 1. So that's a faster way of doing that, and we'll do lots of things like that in this chapter. So we're going to be clearing fractions a lot. So we'll practice that concept. Okay, and the last little bit here. So it says warm up. So Bronwyn drives 50 miles at a rate of 60 miles per hour. On the return trip, she travels at 50 miles per hour. What is her average speed? Okay, so this was kind of a classic SAT question. These always used to be on the SAT back when I was in school. I don't know if they're still on there today. Maybe they are. I don't know. The SAT has changed pretty dramatically. All right, so it is always asked on standardized tests, though. So the key to solving it is to find the total distance and the total time. So what do you guys think? So if she drives 50 miles at a rate of 60 miles per hour, and then she travels 50 miles per hour on the way back, everybody always says the same number. What do you guys think it is? It's okay if you think it. The average speed. So what's her average speed if she went 60 miles per hour and then 50 miles per hour? 55, right? That's what everybody always thinks. It's not 55. Doesn't that blow your mind? You're like, wait, why is it not 55? She had this speed and then she had this speed, right? So here's what we're going to do. All right, so if she's going 50 miles per hour for 50 miles, you all know how long it took her to get there, right? 50 miles, going 50 miles every single hour. How many hours did it take her? It took her 1 hour. We get that, okay? So when we go there and back, the time that it took her was 1 hour. Because she was going 50 miles per hour for 50 miles. Okay. But the other one's a little bit tricky. So she was going 60 miles per hour. Does it take her more time or less time to get there? It takes her less time, right? So we need to think about what fraction of the hour it takes her. Yeah, so it gets a little tricky, doesn't it? So that's where I always think about the distance equals rate times time. If I'm trying to find the time, I'm taking the distance traveled divided by the rate. That's why this first one was 60 over 60, or not 60 over 60, 50 over 50, right? 50 miles at 50 miles per hour, and we ended up getting 1. So if we do that here, if I say the time is equal to the distance over the rate, the distance she went was 50 miles, and she went at a rate of 60 miles per hour. So it took her what fraction of an hour? 5/6 of an hour, right? Which makes sense, less than an hour. So when you're finding the average speed, what you're doing is finding the total distance that you went, and you're dividing by the total time that it took you. Oh, I was writing distance. I was speaking and writing at the same time. Total distance divided by the total time. Right, and that's, again, coming from this equation. If I'm solving for my rate, do you see how I divide by my time? So distance divided by time equals the rate. So in this case, our total distance, she went 50 miles there, she went 50 miles back. How many miles did she go? 100 miles total, right? So we'll write 50 plus 50, which is 100. And the total time it took her was not 2 hours. It was an hour and 50 minutes, right? So it took her 1 plus 5/6 of an hour. So we get 100 over 1 plus 5/6. So I'm going to combine those. So I'm going to have 6 over 6 plus 5 over 6. So we get 11 over 6. You could also do the 1 and 5/6 trick. 1 times 6 plus 5. Do you guys all remember that? So it's really 100 times 6 over 11, which becomes 600 over 11, which if I get my calculator out, 600 divided by 11 is 54.54545454. So 54.54. It's almost 55, but it's not quite, right? If that was an answer on the SAT, you would have gotten it wrong. So tell me, why do you think that she's going slightly less than what you would expect? So her speed was slightly smaller than what we thought it was going to be. You're driving, when she was driving, how long was she driving the 50 miles per hour? How long did that take her? An hour. Was she spending more time driving slower or more time driving faster? Yeah, she spent an hour going at the slower speed, and she only spent 50 minutes driving at the faster speed. So it's not going to be directly half of that. She's going to spend more time going slower. So it's going to be slightly less than what you would think that average of 55 was, okay? Did you guys get it? Yeah. All right, so this is kind of the same thing. So it says Jared averages 3.6 feet per second when walking downhill on a mountain and 2.0 feet per second on the return trip when walking uphill. What is his average speed for the entire trip? Round to the nearest tenth. The only difference is we didn't say how far he was traveling. So you can let it be anything. You can say let x equal his total distance. Well, not total. We'll say distance, like the length of the trail. And we want to find the time that he spent going on each. So when he was going downhill, our time is equal to our distance divided by our rate. He went a distance of x, and he went a rate of 3.6 feet per second. But his uphill time, he's going slower, right? It makes sense that he would go slower. Its distance divided by rate is still the length of the trail, x, and now he's going a little bit slower, 2.0. So what it does is it makes this complex fraction, because we take our total time and we divide by, or total distance and divide by our total time. Jeez, I keep writing time on top. Total distance, and we divide by our total time, right? Because we're thinking distance equals rate times time. So distance divided by time gives our average rate. So our total distance is he went x miles out, or feet out, and he went x feet back. So x plus x. And the total time was the x over 3.6 plus the x over 2.0. So it creates this complex fraction that we were just talking about how to solve. So it's up to you guys. You can solve this using that common denominator approach. Do you guys know what the common denominator would be? Any ideas? No? 3.6 and 2? You could do like 7.2. You just multiply them together always, right? Or you can combine, and so you can say, okay, well, this one's going to be, let me write it on the next step. So I have x plus x, which is 2x. And then I have x over 3.6, and we have x over 2.0. So we're going to multiply by 2.0 over 2.0, and we're going to multiply by 3.6 over 3.6. So we get 2x over 2.0x plus 3.6x all over their common denominator of 7.2. So it gets a little messy. So we have 2x over 5.6x over 7.2, and it ends up, it seems weird, but the x's don't even matter. It didn't matter how long he was traveling on that trail. Because when we multiply by the reciprocal, oops, running out of room. If I have 2x and I multiply by 7.2 over 5.6x, those x's will cancel. So it didn't matter how long that trail was. So we get 2 times 7.2, so 14.4, and we divide by 5.6. And his average speed ends up being 2.571. What was that, feet per second? So it is between those numbers, but the average of those two numbers, if I just added 3.6 and 2 and divided by 2, was 2.8. So see how it's slightly less than the 2.8 because he's spending more time walking at a slower rate. Okay, did you guys get it? That's a hard one. That would be like a bonus question on your test. That's why I have like challenge next to it. All right, so let's stop there.